Okay, ladies and gentlemen, here are some SOHCAHTOA practice problems. And warning, I'm going to go a little fast, and so you need to pause and rewind and watch this video more than once. But anyway, here we go. So here's problem 9 on today's worksheet. And hopefully we agree we have this missing angle right here. Let's just call it little x. Okay? And to find little x, notice that 52 is opposite of x, right? The 49, notice, is adjacent to x. See how it's right next to it? The 65 right here, notice, is by far the longest side. So that's what we call the hypotenuse. Now notice I have all three numbers. So I'm not restricted. I could either use sine, cosine, or tangent. So what about if we just go ahead and use tangent? Now remember with SOHCAHTOA, tangent is TOA, right? SOHCAHTOA. And so therefore I know that the tangent of x simply is the opposite over the adjacent. And so what I'm going to do is take 52 divide 39 on my calculator. And 52 divided by 39, as you can see right there, is 1.33 repeating. And that equals the tangent of x now. And to find x, all I'm going to need to do, guys, is do a tangent inverse. Okay? On both sides. I'm going to do a tangent inverse, or arctan as some people would say, on both sides. And as you can see right here, the tangent inverse of 1.3333 is 53.129. So x, I know, therefore, is simply 53.1 degrees. They told us to round off to the nearest degree, so we're just going to say it's 53 degrees. So pause the video if you need to. Okay, what about this problem right here? Well, again, let's just call our little missing angle down here x. And notice the 72 is opposite of it. 97 is the longest side, that's the hypotenuse. 65 is adjacent. Okay, so again, we could use sine, cosine, or tangent, because we have all three numbers. Now let me just see what I did. I did sine. So I decided to do sine. Now remember, sine is the SO part, right, in SOHCAHTOA. So I know that the sine of angle x has got to be the opposite, 72, over the hypotenuse, which is 97. See that right there, opposite hypotenuse. And so again, I'm just going to do some calculator work here. I know 72 divided by 97 is 0.7422. So I know that the sine of x is 0.7422. And now I'm just going to do a sine inverse on both sides. A sine inverse on 0.7422, because that means x is going to equal, well, the sine inverse of 0.7422 is 47.9. So 47.9. Again, if they have us rounded off to the nearest degree, we'll just simply say it's 48 degrees. So pause the video again if you need to. Okay, what happens though, notice this one is a little different. We're missing a side. Well, we're going to start out the same way. Here we have the 27-degree angle. Does everybody agree x is opposite? And the 16 is adjacent. Now notice this time, guys, we have no choice. All we know is opposite adjacent. We don't know the hypotenuse over here, do we? So we have to be more selective here. What uses opposite adjacent? Well, TOA tells us that tangent is opposite adjacent, right? So that's how I know I'm going to take the tangent of 27 degrees, and that's going to equal the opposite over the adjacent side, x over 16. So as you can see here, guys, I'll go ahead and put this over 1. But when we cross multiply here, x is going to equal whatever 16 times the tangent of 27 is, right? So let's see what we have here. Notice the tangent of 27 is 0.509. And if I take that answer times 16, well, I get 8.15, don't I? 8.515 is 16 times the tangent. So I know this is 8.15. And so rounding off to the nearest tenth, we would just simply say that that was 8.2, wouldn't we? So pause the video again if you need to. Okay. What about this one right here? Well, notice this time the adjacent side is what's missing. Here's my angle 57. X is adjacent to it. 11 is my hypotenuse. So ask yourself, guys, what uses adjacent hypotenuse? Only one of the three. Ka in SOHCAHTOA tells us that adjacent hypotenuse is cosine, right? So we're therefore going to take the cosine of 57 degrees. And we know that cosine of 57 degrees is the adjacent over the hypotenuse. Again, putting this over 1, you can see when I cross multiply, I'm simply going to do 11 times the cosine of 57. And that's going to equal x times 1, which is x. So what's x going to equal to? Well, the cosine of 57 is 0.544. And notice when I take that answer times 11, I get 5.99. 5.99. So therefore, I know x is 5.99. And rounding it off again to the nearest whole number, or nearest tenth, that's simply going to be 6.0, isn't it? So pause the video one more time. Okay, one final one here, guys. So notice on 15 here, guys. Here's my 44-degree angle. X, notice, is adjacent. 14, you notice, is opposite. What function uses opposite adjacent? TOA tells us opposite adjacent is tangent, right? So I know, therefore, that the tangent of 44 degrees is going to be the opposite over the adjacent. Now notice how this ratio or fraction is upside down, right, guys? So we're actually going to do some dividing on this one if you don't know. But anyways, let's find the tangent of 44 first. The tangent of 44 is 0.9656, as you can see there. So we know 0.9656 equals 14 over x, right? Putting that over 1, notice I'm going to take x times point. Let me move it over here. So 0.9656x equals 14 times 1 is 14. And how am I going to solve this? Is I'm going to divide by 0.9656, right? Divide by 0.9656. And so that's what I did right here. Notice I took 14 divided by our answer right here, the 0.9656, right? And here is my result, 14.49. So I know x will equal 14.49. Let me double check that. 14.49. And if we rounded that off, guys, we know x would be simply 14.5, wouldn't it? And so, guys, hopefully this video will help you. Again, if you don't watch my videos and study them, guys, I don't know what else I can do to help you. You need to devote some time inside and as well as outside the classroom. So anyways, until next time, bye-bye.